Hi, in our previous lecture we have learned about the problem solving aspect and its steps. Now we'll be looking at the designing phase. In the designing we create the map for our solution. It's like a map, not actually map, it's like a map. It gives us a way how to solve our problem. In the designing phase we create algorithms. Algorithms help us very clearly in solving problems. Algorithm is a step-by-step description for our solution. It is an ordered sequence of well-defined and effective operations. So when we carry them out, we get the solution, we get the output, and terminate in a finite time. Every algorithm must terminate after certain time, because if it not, so it is going to be in the infinite loop, so it will never stop. The term ordered sequence, ordered sequence means you have to finish the previous step for going further, and it must be, the next step must be unambiguously defined, means it must be very clear to everyone. It must not be so complex to understand, so like easy. History of algorithm is actually, Abdullah Muhammad ibn Musa is a long name. He has created a book, Algorithm. It was actually about the mathematics, so the term algorithm was they get the term algorithm from there. So algorithms are created in two ways: pseudocodes and flowcharts. What pseudocode is? It is an English language directly, not the direct English language. It has a programming like way, and it also has steps. The first step is the start, and the final step is the stop. Start and stop shows us that the algorithm is terminating after a finite time, not infinitely going on. Pseudocode is an informal high-level description of an algorithm that uses the structural convention of the programming languages. So its structure looks like a programming language. It's not the actual program, but it looks like a program, and it does not contain all the syntax of the programming language. What syntax is? It is a grammar. Like we have grammar in English, every sentence must stop with a full stop, right? So in the programming, every line ends with a terminator, which is actually semicolon. So we call it terminator in the programming. It is an outline of the program written in English, so easy to understand, and you can easily write the program after you have seen the algorithm, after you have created algorithm for your problem. What pseudocode looks like? Pseudocode for finding addition of two numbers. So we have to find the addition of two numbers. Step 1 is start. I already have told you start and stop are very important. Start shows us where the algorithm starts, and stop shows where it terminates after a finite steps. So step 2 is declare three variables. What variable is? Variable is a memory location in the program. It's a memory location in the hard disk, like the storage device, not actually hard disk. It must be a cloud storage or anything else, a lot of storage types nowadays. Variables, actually we store the values. Variables are used to store the values. We have to find the addition of two numbers. We have 30 and 40. So suppose that 30 and 40, we have to store these values somewhere, and when we add them up, we have to store their sum in a variable, in a memory location, which we call variables. Variables actually store the data. They store like numbers, characters. We'll be looking at that later. Variables is a full topic in the programming. Read to variables means you have to get the input from the user. User will, like we have calculator in our mobile phones, we always give it an input. Two numbers, three numbers, how much we need to add up, or we have to divide some numbers. We give it the input, and it gives us the result. It gives us the result that we call output. So read to variables means whenever the user will run your program, he must get a prompt to insert the input for the addition of two numbers. Read two variables is like getting input from user. Compute sum is equal to a plus b. So when you insert your data into an calculator, it calculates its sum. So you must give a step where it can calculate the sum of the two variables, and it can print it. So in the fifth step we print the sum. So it's very easy to understand a pseudocode, and it will be very clearly, it will be very easy later when you will understand the variables concept, when you understand the constants, when you will understand syntax errors. It's a lot easier later. So next we create flowcharts. Flowcharts in the pseudocodes we were writing about like the English language directly, but in the flowcharts we create a it's a graphical representation of our problem, of our solution, diagrammatic representation of algorithm. Every diagram is used for one operation, one or more, but in here like we have these diagrams. The oval shape is used to start and end, like here was the start and the stop in step 1 and step 6. So we here write the word the start and the stop, but in our flowchart we use the oval shape. Oval means we have started our algorithm, and oval in the end means we have finished our algorithm. And the parallelogram, it shows us the input output data. In here we declare 3 variables, a, b and sum, right? So actually the declaring 3 variables is not in the flowcharts, it does not come into the flowchart. So we can actually skip this setup in flowcharts. It will make our program our flowchart much easier to understand. We read 2 variables a and b from the user. So in here the input and output, so it is actually the input and output is represented by the parallelogram. In here we have what actually output is. It is the print the sum. The print the sum step 5th and step 3, or step 3 is input and step 5 is output. So we actually use our parallelogram for this. And the third represents the process. We have calculated the sum of 2 numbers, like calculate the sum of a and b. In here it will be represented by the rectangle. And the diamond represents decision making. We will be looking at the decision making later, but here I will tell you the decision making means you make certain decisions, and after those decisions, if the condition becomes true, you can go one way, or if it becomes false, you can go other way. Suppose you are walking through a jungle and you got 2 roads. Your friend is saying this one is dangerous and this one is easy. This one is not dangerous, it is full of peoples, like we can be safe in here, it is safe. So you have to choose the one. So if you want to save yourself, you can go the safe way, from the safe way. But if you want an adventurous travel in the jungle, you can go from the dangerous way. So it depends on the condition. So that condition in there makes a decision. So it is called the decision making. In the diamond shape, we will have to put certain decisions. Suppose if our like we have to calculate the greatest of 3 numbers. We have a, b and c. We have to show which number is greater. We will be looking at the condition. If a is greater than b and c, then print a. So here it will be used as if. So if is a condition here. So decision making, the diamond shape represents the decision making, like it is used to show the if statement or something like that. Here is another, represents the off page connector, and that means if the page has ended, you are creating a flowchart on your notebook. So the page, it is the end of the page, but your flowchart is not completed yet. So you can end a off page connector in the end. So it actually represents the off page. So your page is now finished. You are going to the next page. You have to create this symbol there. So that means it continues from the previous page. Another one is connector. It is a simple connector. Simple connector means on the page, means the page you have finished from one side and you want to create from another side, right? So you can use your simple connector. The document symbol represents for this documentation. What documentation? Any type of hard copy input or output. Like hard copy is actually we are giving input to the printer. It gives us the photo state of something. And the arrow represents the control flow, from where the control flows, where from the flowchart goes and where it has to go. Now here is an example of addition of two numbers. It is the same that we have previously done in by the pseudocode. Here the oval shows the start, then we declare variable a, b and sum. This setup is not actually much important, but why this is written here, because it makes a clear view of the pseudocode. So you can understand it from the view of your pseudocode that we have looked at earlier. Declare variable a, b and sum. Because declaring variables, you have to declare everything. I told you that variable is a memory location. So how can we access this memory by a variable? You have to declare a variable first before you can use it. We'll be declaring the variables later, we'll be using variables later. Here it is a simple addition of two numbers. Go further. So here comes the concept of the programming language. What is actually a computer programming? Computer programming is actually talking with your computer, talking with a machine. Computer language acts as a medium as a medium between the computer hardware and you, like the user. Computer programming is an art of making a computer to do the required operations by means of issuing sequence of commands to it. Whatever you are going to do, say it has to do your work. A programming language can be defined as a vocabulary set of grammatical rules. So every programming language has rules, it has a vocabulary, it has, like, the syntax, the grammar. The grammar is actually the syntax. Here in programming language we say syntax. It is actually grammar for computer programming languages. There are a lot of types of lots of the computer programming language. Like BASIC was an old programming language. C++, well, not much old. Java is old, but they still that is so famous. Nowadays Python is used so much because that has got so many users, and its users are increasing in very fast speed. COBOL, Fortran, Ada and Pascal, these were very old programming language. Now these the people know they are very rarely used nowadays. Introduction to C programming language. C is a general purpose high level programming language. It is a high level, so we have low level and high level. What was the low level? In low level programming language we don't need the mediums, right? We write the actual computer code which computer can understand directly. But in high level language it is completely like an English language. So most of the words are like English language, but we need a compiler, we need a software that can convert this English language into the machine language so the computer can understand. So C is a high level language. Why high level languages? Because these are easy to understand, these are easy to learn, and the old low level languages are very difficult to learn and very difficult to write and find the errors in that. And little history of C language. It was developed by Dennis Ritchie in the Bell Laboratories in 1972. Don't need to know a lot of histories about the programming. If you want to go for the software engineering, game development, don't have to look for a lot of history in the programming.